Example 2, given the functions f of x is equal to the square root of x minus 1 and g of x is equal to x minus 2. In A, we're going to determine the equation of the function h of x by subtracting. So h of x is going to be the f of x graph minus the g of x graph. So f minus g of x, I like to write it this way so I can visualize my equation. So we're going to put f of x graph in there minus the g of x graph. So you need to put brackets because you're subtracting that binomial. So we're going to multiply the negative sign now through the brackets. Our radical stays the same. And these are not like terms, so we actually can't combine those. So that is as far as we can go. Let's look at B now. Sketch the graphs of f of x, g of x, and h of x. So our f of x graph is our square root graph shifted to the right one. So our end point is going to be here. And then remember, we would go up 1 to the right 1, up 2 to the right 4. So you're basically graphing like that same pattern on a parabola, but it's going to be a sideways parabola. So we graphed radicals before. So this is going to be our f of x graph. Oops, sorry to bump the camera there. Let's get this so we can label this. Okay, now we're going to graph g of x. G of x is going to be our linear graph. So it's a straight line graph. So our y-intercept is -2. We're going to go up 1 over 1, and we're going to continue our slope of 1 in both directions. I have a few points there, and this is our g of x graph. So our linear graph. We're going to label that since we're graphing more than one equation. Arrowheads on both ends here. And now we're going to look at graphing this. Now, this we've never graphed before. It's a radical and it's kind of got this tail end. So it will actually look similar to this with a bit of a shape of this plus a bit of a linear shape to it. The only way we're going to know what to do on this one is we're going to have to use a table of values. So we have to consider the restrictions as well. So when we're putting in a radical here, we have a restriction with radicals. So for our restriction, x minus 1 must be greater than or equal to 0. So x must be greater than or equal to 1. So 1 is the smallest x value I can choose in my table. And so then I'm going to plug that in here into my, so I'm going to go 1 minus 1 into the equation, minus 1 plus 2. So you're going to calculate that, and you're going to get 0 minus 1. So -1 plus 2, you're going to get 1. 2 is a good value to pick because 2 minus 1 would give me a perfect square. So I'm sort of choosing selectively now. So 2 minus 1 minus 2 plus 2. So you're going to plug that in, and you also get 1 when you do that. Square root of 1 is 1. Those cancel out. Now I could choose 3, and that's an okay point. 3 minus 1 gives me the square root of 2, and I could use a calculator, and we may consider that. But I'm going to try at first just to choose values without, plot those points and then see if there's other points I want to test. So the next x value I'm going to choose is 5 because 5 minus 1 will give me 4, and I'll have a perfect square. So I'm going to choose 5. 5 minus 1 minus 5 plus 2, so I get the square root of 4, so I get 2. 2 minus 5 is -3 plus 2, so you're going to get -1. And I'm going to choose one more point, the x value of 10. 10 minus 1 would give me 9. So we're going to plot that one as well, just to see if there's much of a difference. Those points are in there, so you're going to calculate that. So you're going to get 3 minus 10 plus 2, so you're going to get -5. So let's plot those points. Use a pencil here just so it looks different. So you're going to have 1 and 1. You're going to have 2 and 1. Then you're going to have 5, 1, 2, 3, 1, 2, 3, 4, 5, and -1. And I think it's important to still plot this point. So we're going to just extend this as best we can here. I'm going to have to probably move my camera over a little bit here. So we have 5, 6, 7, 8, 9, 10. And then we're going to go 1, 2, 3, 4, 5. So we're going to plot this down here. I clearly need to label that point since we're off our grid, which is going to happen sometimes. And we're going to connect these. Now, We don't necessarily want to assume that this is a perfectly horizontal line. We kind of got lucky there. So if you didn't have a calculator, you could put this in here and, you know, you kind of don't know, but I don't think it's such a rigid line. So I would test one more point. So I would try 1.5, which you would need a calculator for. And so if you've got your calculator nearby, put that in your calculator. So you're going to square root 1.5 minus 1. And when you do that, you're going to get 1.2, etc. So this is not a perfectly horizontal line. It does go slightly above that point. So this has actually got like that curved shape here, like a radical graph would probably, you could predict, and then it goes down through here.